8.4 has more rules or more theorems and postulates on chords, angles, tangents, chords, and circles. Which actually, this is the fun part because this is where like all the x solve for x comes in.
Easy
That-
stuff.
Personally, I think it's much easier.
Algebraic.
Well, if it's algebra.
So tangent and chord theorem says this. If a tangent and a chord intersect on a circle, then the measure of each angle formed is 1/2 the measure of its intercepted arc. So what that means is, if the measure of angle BPF, so BPF, it would equal half the measure of
Close.
arc BEP.
That's very much
Which is
easier.
basically what we did yesterday, right, with the, arc that's inside, or, listen, it's basically the same rule yesterday. Remember how yesterday, if our angle touched the side, it was half of what the arc is that it intercepts? This is the same thing. If I have a tangent line and a chord, because they touch the circle, yes, the outside of the circle, then their angle is half of the arc that's inside of it. Okay? So then angle BPD is 1/2 of arc BAP. Okay? So if you know any of those arcs, you can find out the angles. If you know the angles, you can find out the arcs. If you know one arc, you can find out the other arc and the other two angles. Yes? Okay. Chord angles inside circle theorem. Pretty much tells you what you're doing. You have two chords inside a circle. Yes? If two chords intersect inside a circle to form an angle, then the measures of the angle equals 1/2 the sum of the measures of the arcs intercepted by the angles and its vertical angles. Meaning this, if you have chord MR and chord NQ and they intersect, then the measure of angle MPN, this angle right here, MPN, okay, will equal 1/2 of arc MN plus arc QR. So you add those two arcs that they intercept together, divide it by 2, and now you know what those angles equal. And since they're vertical angles, they are congruents. Okay?
Congruent and equal are the same thing, correct?
Correct, but we use the word congruent more frequently in that.
Okay. I just thought that I was being dumb.
Okay? So you're gonna add the two arcs they intercept on the outside together, divide them by 2, and you got the angles on the inside. Boom. The other one is,
It's like I'm so drunk.
and that's when it's inside a circle. The other one's when it touches the outside of a circle, it's only half of the arc. This one's on the inside of the circle, add 2 arcs, divide by 2. Lots of dividing by 2 here.
Easy. Choose a very small number. I can deal
What
with
are
that.
you asking me, Abby? Arc, look, angle MPN or angle QPR. They're gonna be equal, yes? Either of those angles you find by adding arc QR, arc MN, and dividing by 2. Okay?
Just go into the book. It's on page 381.
Yeah, I got it.
Okay. Then we're going to move to the next slide. Okay, angles formed outside of a circle theorem, okay. So listen, there are 3 different types of angles you can form outside of a circle. One looks like this, okay? Where we meet, the circle is basically all on the inside. Here's what happens. Angle MPN is 1/2 of the larger arc MQN minus the minor arc MN. So the larger arc minus the minor arc
That's a lot of pickers.
divided by 2 gives you that angle. That's smaller arc, divide by two, gives you that angle. So here's the deal, on your homework, they're not always gonna say, here are what the two arcs are. They might say, tell me what arc MN is. Well, you'd have to work that equation backwards, yes? Okay, so don't just think it's this, divide by two gives you this. You have to work stuff backwards sometimes, I know, miracle, right, Brandon? Okay.
Yeah.
Okay, if you notice this one up here, look, this has a tangent line, yes? And then it has a line that is, secant to it, cause it goes through it twice, yes? A line that's secant to it, okay? It's the same type of concept. You're gonna take this larger arc of MQ, and you're gonna subtract it from MN and divide by two. So really, essentially, it's the same formula,
Yep.
okay? And then if you notice this one, it's two secants, yes? Okay, once again, it's this larger arc right here, minus the smaller arc divided by two. So it's the same formula, no matter how it looks, yes.
What if they don't give you the measure of the arcs? How do you?
They'll give you enough information that you know that like one is double it, or one, and then you'll say like 2x and x,
Okay.
or whatever. Does that make sense? Okay, the next one is secants and tangents theorem. So that means you have a secant and you have a tangent, okay? If secant and tangent segments intersect outside a circle, notice how those do not continue, correct? Up above, these all continue, yes?
What do you mean? Oh, through the thing.
Yes, do you see how those arrows tell me that these lines are going on forever on all three of those? This one literally stops, yes? Okay? Then the product of the lengths, product means what?
Multiplication.
Okay, the product of the lengths of the entire secant segment and the secant segment outside of the circle equals the square of the tangent segment. Which one's secant, which one's tangent?
Secant
Tangent is
is
BA.
BE.
Okay, BA. So BA squared equals BD times DE. BA squared equals BD times DE.
The product of the secant and this, okay.
So when I square the tangent line, it is set equal to the two portions of the secant line being multiplied together, yes?
So would you do BDE times BD?
No.
Or BD times DE?
Repeat.
Cause it says the
It's
length
yes, it's BD times the whole. It's the outside times the whole.
times, okay.
Okay, to make that clear, sorry. It's BD, which is the outside portion of this, which matches basically the BA part, times the whole. So it's this larger portion times the whole, equals this side squared.
I'm still writing down the English for high school.
Like 2 out of the 7 slides.
The rest are just example problems.
Are you sure?
Probably.
Yeah, cause that's the last, year.
Sorry, all day I've been like that.
Oh, wait a minute.
Oh, you were wrong,
Yes.
Chloe.
What?
You were
Oh,
wrong.
it's back.
What do you still need?
You were wrong.
Last 10 words.
You don't have to copy it word for word.
Just say,
That's
Well,
what
it's
I'm
better.
saying.
with a secant and tangent, the product of the secant and the part outside the squared is the tangent.
Okay, well, good job.
Thanks.
Mhm.
I just like the one for word because it's more words, so it helps me remember better.
Alright, you guys gotta get better at this copying thing.
Just
Do
do
you
the
like-
ones under the pickers.
Here's the thing, maybe it's cause I'm good at memorizing, so I'm asking, cause I don't know how
Or
to
you're
read.
good at math.
I'm gonna.
No, I mean like, I literally can memorize.
Yep.
Oh, no,
I
no,
can
no.
memorize.
I'm just really bad.
I can look at something
I
3
have
times and have the
photographic
whole thing
memory.
memorized.
I can do that with.
So what I do is I literally read a sentence and then just write the sentence out, and then read the next sentence and write the sentence out.
That's what
The
I
Bible?
do. That's
I
what
can-
Which is why you get done so
Quoted by
much.
Sam?
When I hear someone like
Do you want me to
say.
record if I-
Yes, I can do that too. If I hear it, I also can remember it and do it.
Yeah, I got it.
Okay, chord lengths theorem, chord lengths theorem, okay? So this looks very similar to which other theorem that we just talked about?
The chord angles inside
This
the
one.
circle theorem.
Okay, so this one's only dealing with length though, yes, lengths?
Sure.
The product of the segment lengths of each of two chords that intersect inside a circle equal one another. So if I take MP times PR, it's going to equal NP times PQ. So if you multiply the two segments together of one chord, you can set them equal to two segments of another chord multiplied together if they intersect.
A lot of memorizing.
If your chords intersect, yes, it is a lot of memorizing. But it's a lot of stuff that makes your life easier because it's just simple formulas.
I think what takes me longer is I draw the pictures.
Me too.
I'm
So
still,
tomorrow, while you work on review problems in class that I'm going to give you, because it is a massive packet, and I'll have the answer sheet packet too.
It's a long.
It is,
packet.
because Margot copied it
I
for me.
copied it.
It should give you
It's a
plenty of practice on
long
all this.
well, let
You
me,
need to start remembering which goes with which, because it is not on your quiz for you.
When is it given?
What's not on our quiz?
How many verses do we have?
I'm giving it to you tomorrow for review. I have it in Power School, but I probably won't collect it as a grade. It's just for your benefit for the quiz on Thursday.
Miss
Don't
Green.
take it lightly, do it just in case.
See, the thing is, you can tell.
I have it in as a grade right now, but we'll decide.
You can tell us that it isn't for a grade, but since we're honors, most of us are still gonna do it just because we
Well-
want to be able.
Not Alex.
I said
Not me.
notice how I said
Not
most of us.
Okay, can I switch?
I
Yeah,
do
yeah.
it.
The Pinterest.
Is that
Lies.
all?
Literal lies.
Okay, here's what I want. I want to find the measure of angle BAD
Bad,
and the measure of arc BOA.
boa.
Boa constrictor.
How can I find the measure of angle BAD?
You gotta know what BA is.
No, I don't.
You need to know what BL.
BLA.
I do know what BLA is. What is it?
So that's how you
Oh,
figure it
so
out.
it's
105.
105. Good.
That's
What is
I
the measure
said.
of arc BOA?
B.
120, 150, 150, 150,
150
150.
because
Yep.
I got that
Zero.
one.
BAX, angle BAX is
No.
75, so just double.
I definitely got that one.
Okay.
I was behind you, so Blaze, you were closer.
Okay.
So I definitely had it first.
How do I solve this? This says X, this says MX is X, this says XY is 4, this says, this is 8, I believe.
Oh no.
X, yeah.
You're
X times X.
Good, no, not 4X.
X plus 4
X plus 4
times X
times X.
equals 8 squared.
Now what do I have to do?
Oh, it's right there.
Yeah, but
Third.
boy, yeah, I gotta distribute.
Negative
X squared and 4X equal 64, so X squared
Yes,
plus
sir.
4X minus 64 equals 0. What do you get?
Wait, a.
9. Like 9.
I got 12 and 4.
That's what I. Nope.
No, I didn't.
No, you did not.
I told you.
Doubt.
16.
I got 16
Well,
and.
multiplies to give you negative 64, adds to give you 4.
I don't remember how to do that. That was algebra. I didn't pay attention in that class.
Yeah, Chloe. No one asked.
Multiplies to give you negative 64, adds to give you 4.
Okay, I think it's
I'm trying.
what else is it? What are multiples of
You do 4.
16.
16 and what?
4?
No, that's
Well,
No,
no.
because 16 minus 4 is 12, or 16 plus
You know
4
what
is
happened?
20.
Hey, Caleb.
Is it
It's me.
possible?
Sorry.
I don't think so.
If it's not possible, what do you have to use?
I thought it was
My brain.
X.
Undefined.
Nope, it's something.
IMS.
X equals negative b plus or minus the square root of b squared minus 4ac all over 2n.
Are we
Beautiful.
really?
No,
doing
no,
that?
we are. I was
X
thinking
equals
about that the other
negative
day.
b.
I was
Yes,
going to
you are doing that, Courtney. So, when it is not factorable, you have to use the quadratic formula.
I want to kill myself.
Okay, so I plug in 64 plus or minus the square root of
B squared minus
b
4AC.
squared
What are we finding?
minus,
What's A and C?
what is a and c?
I don't know.
A, c, oh wait,
I don't think that we can use this formula.
yes you can.
We can though?
Opposite of b, this is b,
Okay.
plus or minus the square root of
Oh, it's just A, B,
b
C.
squared minus 4 a c, yes, all over 2.
Times 1.
Wait, where's the one going?
Oh,
So
oh,
what is-
children, you will use this every day in Algebra 2 almost. Do not think, when you graph quadratics, this is the.
So I don't want to hear about graphing until next year.
Wait, how does?
One,
Where's A?
That's so.
What do you mean, where's A? A is 1.
No, I mean on the picture.
It's
It's just A, B, C.
A,
So it's like
B,
A, B,
C.
C. Oh, never mind.
This
This
means
is-
yes. 1, 2, 3.
so it says, I forget, does the square disappear in A? Because it's a one.
Wait, time out. What do you mean does the square disappear in A?
I mean like,
You go by the leading coefficients, the x has nothing to do with it.
I mean like,
What do you mean, Margo?
Do you believe we could?
Guys, shut it and start doing the math. I'm stopping there, you gotta tell me the answer.
Can I take a picture of that?
Later.
Well, I'm just
Margo,
kind
what
of-
are you asking me?
cause like when you put in, I forgot that you go with like the leading
I was-
coefficient.
Uh-huh.
And so I thought that like when, so it's like x, like one,
Add
like,
that.
it's like one squared.
You're asking
And so I thought that you
I
just
figured
like
out the
already
plus
worked
and
it
the
out,
square.
and so
One
it
is
just
not
be
square.
one. Okay.
Oh, and then going at 2 different.
Mm-hmm.
Yeah, so you gotta get like.
And you
one
gotta
plus
tell
one
me,
there.
use common sense, which one would be x, the positive answer or the negative answer?
It's positive.
Why?
Because
You can't have.
you can't have a negative length.
Good.
It's impossible.
So,
So.
don't we have to be doing like a priority list for schedules? Don't you have to have your schedule in by Thursday, by
No.
Friday?
Counterclockwise.
Yeah.
Counterclockwise.
Has anyone like already have their schedule in?
The black one.
No, I don't have my schedule in because I forgot.
I
Has
did.
anyone actually done that yet? I'm going like.
Has
gonna
anyone
do it.
actually solved this yet?
Yeah,
I'm
no.
going, what'd you get? What did you get? No. Definitely not.
You do the plus and then you
What'd you get, Abby?
6.25.
Yeah, your guys aren't using parentheses, right? 6.25.
So you add them and then you square root them and then you plus and minus them and then you divide by 2.
When you add those, you get 272, yes?
Yeah.
Take the square root of 272.
And then you
You
have
get
to separate it.
16.49.
And then you separate it, right? You separate it.
Yeah, you do -4 plus.
And then do -4 plus 16.49.
And then -4
And you
minus.
get 12.49 and then divide it by 2 and you get 6.25.
I just did 16.
So they wanna know what the length of MY is, right?
Yes.
So I have to add 6.25 and I have to add it to what now?
4.
4.
Solid.
So then 10.25 is your total length.
Okay, so.
The other one, the negative equation was -10.25, right?
Why do we add the 4?
Because it said what is the length of MY and the length of MY is x plus 4. What, Margo? Question? Okay, here we go. AE is one longer than BE, and CE is 2 longer than BE, while DE is 4 longer than BE. What are BE and DE?
So you find out CE.
So
and
look, they
AE.
even labeled it for you. X plus 4, because it's 4 longer than BE.
Is equal to 360.
X plus 1, X plus 2, right?
So
Because
what
they're
do
all
I do?
compared.
To find out x, if the
Don't you have to mod it to 360?
b is.
So just set 2 of them equal to each other. Set
No.
x equal to
Timeouts. Why don't you think about the rules you've learned today and figure out what you're supposed to use?
Oh, I know what to
chords
do.
inside a circle theorem.
Chords lengths, Dan. Each
Chords
section of
length.
the chord multiplied together equal each other.
If the chords what?
Intersect,
Intersect.
so therefore.
So you can do x times x plus 4, yes?
Equals x plus 1 times x times
Correct,
2.
so you need to do x times
Do we
x
have to
plus
FOIL
4
that?
equals, Yeah, welcome
I
to,
hate foiling, I hate algebra.
well, you're gonna get a lot of it when it comes to circles from now on out.
I like geometry.
So then x times x is,
I like shapes, not numbers.
and then x and 4 is, and then x and x is,
Squared.
and you get 2x and 3x, and I get 2. Now what do you have to do?
I like turning.
Get them all to one side.
Yeah, so
One
zero.
side.
I'm gonna do this.
Subtract x
No,
squared
it's x plus 2.
minus 3x, so it just x equals 2.
So then what do you have to do?
Plug.
Plug and chug.
Plug and chug. So BE is,
There's
Two.
not an E up there.
yes there is.
D, yeah.
AE is,
AE is 3.
EC is, and DE is. So look at this, 6 plus 2 is what? 8, and then you had 4, wait, that doesn't make sense.
Really?
Oh, it's
Was
not
that really
6.
necessary? I mean, yeah.
Yeah, yeah, so you have to solve like that, perfect.
I'm gonna keep
Show
it.
me work.
See, I can do it. No. No. Wrong. No.
Why not?
I love Amsco.
Go to amsco.com.
Is that our homework?
No.
Go to amsco.com/.